The geometry of invisibility. Why the B-2 Spirit is an engineering miracle. Some machines are impressive, some machines are dominant, and then there's the B-2 Spirit. This is an aircraft so advanced and so impossibly expensive, it can fly halfway around the world, deliver a devastating payload, and simply vanish. It costs over $2 billion per plane, yet on a radar screen, it can appear as small as a bird. How on earth is that possible? Well, the secret isn't just in the classified materials or the advanced electronics, it's in the geometry. It's in the pure, deliberate, and radical shape of the aircraft itself. This is the story of how engineers bent the laws of physics to create a machine that could literally become a ghost. We're going to reveal the geometric secrets that allow a 170-ton bomber to slip through the most advanced detection systems on Earth, a $2 billion miracle of invisibility. The problem: a wall of threats. To understand the B-2, you have to go back to the Cold War. Imagine a line drawn across Europe, the Iron Curtain. On one side, NATO. On the other, the Soviet Union and its allies, protected by the densest, most sophisticated air defense network ever created. It was a digital fortress of overlapping missile batteries and fighter jets, all linked together, ready to find and obliterate any intruder. For the United States, this was a huge problem. Their main bomber fleet, the mighty B-52s, were powerful, but they were from another time. Against modern Soviet radar and surface-to-air missiles, a B-52 would light up a radar screen like a Christmas tree. Flying high was a death sentence. Flying low to hug the terrain was incredibly dangerous and put massive stress on the crews and the planes themselves. The newer B-1 bomber was designed for that low-level dash, but even it was becoming vulnerable to new and improved air defenses. The US needed something that could bypass the fortress entirely, not by outrunning the threats, but by being completely invisible to them. The mission was almost science fiction. Create a bomber that could take off from home base in Missouri, fly deep into the heart of enemy territory, strike its targets, and return home without the enemy ever knowing it was there. The answer came from a project so secret it was known only by its code name, the Advanced Technology Bomber Program. The solution: the geometry of invisibility. The answer to this impossible problem wasn't just one single thing, but a symphony of innovations, and the conductor of that symphony was its shape. First, and most obviously, the B-2 is a flying wing. It has no separate body and, most importantly, no tail. A normal plane is a collection of shapes: a tube for the body, slabs for wings, and a big vertical fin at the back. To a radar system, that's a party of right angles, and a right angle is radar's absolute best friend. When a radar beam hits a vertical tail, it bounces straight back to the receiver, basically shouting, "I'm here!" The B-2 gets rid of these vertical surfaces completely. Its design is all about continuous curvature. There are no sharp edges or flat planes facing forward. Think of it like a tilted, curved mirror. When radar waves hit the bomber's leading edge, they aren't reflected back to where they came from. Instead, they're scattered away in 1,000 different directions. The energy that does return is so faint it gets lost in the background noise. This reduces its radar cross-section, how big it looks on radar, to an astonishing 0.1 square meters, about the size of a small bird. But a flying wing is naturally unstable. Without a tail, it wants to flop all over the sky. The only reason the B-2 can even fly is a quadruple redundant fly-by-wire computer system. It makes thousands of tiny adjustments every second to control surfaces hidden on the wing's trailing edge. Instead of a rudder, the B-2 uses split panels at the wingtips that open to create drag, gently nudging the plane left or right without creating a vertical surface for radar to see. The pilots don't really fly the B-2. They tell the computer where they want to go, and the computer figures out how to do it. The skin and the guts, more than just a shape. Geometry is just the first layer of invisibility. The next is the B-2's skin. The aircraft is built mostly from advanced carbon graphite composite materials. They're lighter and stronger than aluminum, but they also do something incredible. they absorb radar energy. So while the shape deflects the waves, the material itself acts like a sponge. This structure is then coated with a top-secret layer of radar-absorbent material, or RAM. This special paint is filled with microscopic particles designed to trap radar energy and turn it into heat. This is why maintaining a B2 is so ridiculously difficult and expensive. The RAM coating is extremely sensitive to heat, moisture, and even small scratches. After almost every flight, ground crews spend hours inspecting and repairing any tiny flaw, because a single imperfection could compromise the plane's invisibility. This is why B2s need special climate-controlled hangars, not just for the electronics, but to protect the delicate skin that makes them ghosts. The final piece of the puzzle is hiding what's inside. A jet engine is a massive radar reflector and a huge source of heat. The B2's 4 engines are buried deep inside the wing. Air is fed to them through S-shaped intake ducts. This winding path means there is no straight line for radar to see the spinning fan blades. It's like hiding something around a corner. The engine's heat is handled just as cleverly. Hot exhaust is mixed with cool air and vented out over the top of the aircraft, masking the heat from infrared sensors on the ground. And, of course, every single weapon is carried internally. The moment the bomb bay doors open is a calculated risk, a brief moment of vulnerability in an otherwise impenetrable cloak. The result: an engineering miracle in action. Combine the geometry, materials, and internal design, and you get an aircraft like no other. The B2 can fly over 6,000 nautical miles without refueling, and with just one top-up in mid-air, it can hit any target on the planet. It can carry a 40,000-pound payload, enough for 80 500-pound smart bombs or 2 of the colossal 30,000-pound GBU-57 bunker busters. Its stealth means it can penetrate enemy airspace without needing fighter escorts or jamming support. As a testament to its design, it was reported as of late 2013 that no enemy missile had ever been launched at a B2. But this power comes at a mind-boggling cost. The program, which originally planned for over 100 bombers, was capped at just 21 aircraft. This drove the average cost, including development, to over $2 billion per plane, making it the most expensive aircraft ever built. The operating costs are just as wild, estimated at around $130,000 to $150,000 for every hour it's in the air, mostly because of the intense maintenance its stealthy skin requires. The B2 Spirit is a machine born from a specific Cold War challenge, but the principles of its design, the geometry of invisibility, are timeless. If you enjoy seeing how legendary machines like this actually work, make sure to subscribe and hit the bell icon so you don't miss our next video. And tell us in the comments, what other piece of incredible engineering should we look at next? For over 30 years, the B2 Spirit has been the ultimate symbol of American air power, untouchable, unstoppable, and awe-inspiring. It's more than a bomber, it's a landmark achievement in science and engineering. Today, the B2's legacy is already taking flight. Its successor, the new B-21 Raider, is built directly on the same flying wing concept. The B-21 is designed to be smaller, more durable, and uses next-generation stealth that makes it even harder to find. It's proof of the enduring power of the B2's original idea. The Spirit taught the world that the path to true invisibility isn't about brute force, but about elegance, subtlety, and above all, geometry. It remains a silent, flying monument to the very edge of what's possible.